Hubhopper Originals.
To start your podcast for free, log on to studio.hubhopper.com.
Hello, everyone, and welcome back to Indian Genes. As promised, this is a blockbuster episode with a very special person that has visited us before and is currently leading the Galileo Project, something that hopefully will answer the question of, are we alone in the universe? We discuss details of the project and what the expected goals are from a scientific perspective where information needs to be valid, verifiable, and authentic before making any conclusive claims. Last year, he released the global bestseller, Extraterrestrials, that has also been translated into over 25 languages, and we highly recommend this book to those of you that have not yet read it. He received a PhD in plasma physics at the age of 24 from the Hebrew University in Jerusalem and was subsequently a long-term member of the Institute for Advanced Study in Princeton, where he started work in theoretical astrophysics and later moved to Harvard. He is now a professor at Harvard and the former chair of the department. There is a lot in this conversation that you will be hearing for the first time, as he has not shared this at any of his other interviews, and we also get to know more about the person beyond his work, and we would like to thank him for that. He's been very candid and very informative in this discussion with us. So sit back and enjoy this Indian Genes exclusive with a very special person, Avi Loeb. So Dr. Avi Loeb, a very, very big welcome back to Indian Genes from all of us here in India. We do remember the last time you spoke to us was about a year ago, and we now call you a good friend of everyone here in India and Indian Genes. But before we get to so much that we have to talk about, how has it been for you? And we would like to know a little bit more.
Well, it's a great pleasure to join you. I'm just back from a trip to Miami, Florida, where I was asked to participate in the concluding session of Bitcoin 2022. And you might wonder, why would they be interested in astrophysicists joining them? And the title of the session was Save the Money, Fix the Money to Leave the World. So they need a purpose. After fixing the money system with Bitcoin and cryptocurrency, the question is, what can you do with the money? And of course, there are lots of risks here on Earth, and one way to provide a better future to humanity is to consider space.
Absolutely. And I have been following you at that conference as well. And I would quote what has been posted by the Galileo Project as well. And we will come to the Galileo Project in some time. That says that you hope that the discovery of advanced intelligence will make us realize that we should treat each other with respect as equal members of the human species.
Yes, that's exactly right. I think what we lack is a sense of modesty. And if you look at human history, much of it was guided by arrogance. And for example, we used to think that we are at the center of the universe. That turned out to be wrong. And we used to think that the Earth-Sun system is unique and privileged. And we were proven wrong. Now we know that about half of the sun-like stars have a planet roughly the size of the Earth at roughly the same separation. So the universe keeps sending us these messages that we are not that important. In fact, we came to exist as an intelligent species only towards the end. The universe existed for 13.8 billion years. So if you arrive to a play and you realize that you are on the stage just at the end, that's a clear message that you're not the main player. And we refuse to accept that message for many centuries. And I think it's about time for us to approach the universe with modesty. And there are two flavors to it. One is to recognize that perhaps what we see around us is not privileged, that, that we are sort of in a typical place at a typical time right now. And therefore, there could be many others like us or even better than us on the cosmic block. And the second aspect of that is if indeed there are kids on our block, and we shouldn't sit at home and argue we have no neighbors. We should look through the windows and maybe go out and play with them, because if there is a smarter kid on the block, we can learn from that kid and advance our knowledge, and perhaps that could help us uh, behave better and in a more intelligent way adapt to the reality that surrounds us. So there are benefits to recognizing reality, and that's what science is all about. Science is about understanding the reality that we all share, rather than attaching goggles to our head and living in some virtual reality where we play a much more important role.
Right. And talking about looking out through the window and science, we are all really excited about the Galileo project here in India. And the way I see it is, I guess for any project this size, you probably need a idea. You have the idea, and it needs to be timed right. And I don't think there's any better timing than this. And then comes in the third component of expertise and then testing out and launching that particular project. So why don't I let you talk to us about the Galileo project and give us an overview of how exactly you plan to go forward with this, and how easy was it for you to put these current 100 plus scientists together under your umbrella in this Galileo project?
Yeah, so it all started with the book that I wrote, Extraterrestrial, that was published a year ago and became a bestseller in many countries, 25 languages. And um, so a lot of people showed interest. I had 2,500 interviews over the past year. But interestingly, a few multi-billionaires visited the porch of my home, and they were inspired by the message and decided to contribute about $2 million to my research fund at Harvard. And that allowed me to establish the Galileo Project. And um, it was based on the experience that many of my colleagues in academia pushed back against the message that I was trying to deliver, which is that this object, the first object that we spotted near Earth as coming from outside the solar system, looked very weird. It was named Oumuamua, didn't look like a comet or an asteroid that we've seen before. And the proof to that is that the mainstream proposals to explain it all invoked something that we've never seen before, like a hydrogen iceberg, a nitrogen iceberg, or a cloud of dust particles. And if you need to suggest something we've never seen before, it means this object is weird. And it was the first. And for me, it was a wake up call that we need to do archaeology in space, or I call it extraterrestrial archaeology, looking at objects that arrive to us from outside the solar system, because some of them may be artificial in origin. And perhaps the first one, Oumuamua, was artificial. That was my suggestion. So the claim was by the mainstream: extraordinary claims require extraordinary evidence. And my response to that, I mean, this was a statement made by Carl Sagan, which frankly I don't agree with, because what you need in science is evidence, and the point is, my point is, extraordinary evidence requires extraordinary funding. If you don't engage in the search, if you don't allocate billions of dollars to the search, then you cannot argue that the evidence should have been here in the first place. Because I'll give you an example. We don't know what most of the matter in the universe is. It's quite embarrassing, because for 100 years, astronomers studied the universe and realized since 1933, Franz Zwicky identified dark matter in clusters of galaxies. Since then, we realized that there is 5 times more matter than ordinary matter that we are made of, 5 times in mass. The mass budget is dominated. 83% of it is in the form of dark matter, meaning matter whose nature is unknown. And we just call it dark because it doesn't interact with light and with ordinary matter. So we don't know what it is. And it became mainstream at some point, the discussion. Of course, early on, it was not out of the mainstream until the early 1970s. People disregarded it. But then it became mainstream because the evidence was beyond any doubt that it affects gravitationally the ordinary matter. And so it should exist. And then we invested billions of dollars in searching for the nature of dark matter. And the most popular particle when I started astrophysics uh, was the lightest supersymmetric particles. So people talked about some weakly interacting massive particles that are very natural, and they said we should look for them. And uh, a lot of money was poured in that direction. And most recently, the Large Hadron Collider at CERN, it cost $10 billion, and one of its main goals was to find the natural parameters of this weakly interacting massive particle as the lightest supersymmetric particle. And after investing $10 billion, we haven't found it. My point is, we haven't invested in the search for equipment from other civilizations. That's a search strategy that was never attempted. And all we did was look for radio signals, which is a very different approach. For that, you need the counterpart to be active. And it's just like trying to have a phone conversation. Whereas if you do extraterrestrial archaeology, you are looking for relics left behind. The sender may be dead by now. So this approach was never tried. And if we invest billions of dollars in this approach, and in 40 years we find nothing, then we would be at exactly the same point as dark matter searches are right now. And the dark matter searches are part of the mainstream. So my point is, let's do the search first before arguing that we don't have extraordinary evidence. Because if we were to argue that about supersymmetric particles, that there are extraordinary claims and therefore we shouldn't engage in searching for them, then we wouldn't invest the money that we did in the Large Hadron Collider. And my point is, science is done in a way by which you search for evidence, and only then you can argue that you don't find it. You can't just imagine the evidence landing on your lap. Even to detect gravitational waves, we had to invest $1.1 billion by this National Science Foundation in the US. And so things that do not require investment of funds are considered part of our day-to-day reality. I mean, we see birds. We don't need to invest funds in searching for birds because we see them all the time. So, of course, if extraterrestrial equipment was all around us, we wouldn't need to invest the money, and then it would be part of our reality. But anything beyond that requires the search. And my point is, let's look through our windows and search.
Right. And when you talk about this kind of investment or economic investment into a project that a lot of us know is or has been looked on differently by the scientific community, I think it's very important that certain ground rules or principles are upheld in a project like this. And you have set three of them for the Galileo project, and I could just briefly let you touch on those, which is you are only interested in scientific data that is openly available, and the data analysis will be you would not touch on fringe areas about these extensions, and you would like to protect the quality of its scientific research. So setting a stage for this, would you want to just give us a little bit of a insight into these three principles or rules?
Yeah, so basically, we are following the scientific method. And the scientific method implies that first you need to build your own instruments. You can't rely on eyewitness testimonies. That may hold in court in the legal system, but not in science. In science, you have to base any statement on instruments that you have full control over so that you know what they are doing and you can calibrate their errors, and collect data that is open. That's extremely important because the government has data that is classified. We don't want that. We want data that any scientist, any person in the world can look at. And the sky is not classified. That's the good news. So we can look at the sky. I mean, astronomers are doing it, but they're not looking for things that I'm talking about. And also, I mean, there are lots of speculations about possible new physics, and that we will have to contemplate only if we are with our back to the wall, so to speak. So for now, we will use the known laws of physics to interpret what we see. And of course, if we see something that cannot be explained, for example, some object moving faster than light, then of course we have to contemplate a deviation, some extra physics that we are not aware of. But for now, the project will operate based on the known physics and technology that we understand. And so these are the principles. And then the Galileo project itself has two branches. One is aimed to find the next Oumuamua, this object that was discovered in 2017 that came from outside the solar system that looked weird, perhaps artificial. So in a year, uh, there will be a new observatory operating called the Vera Rubin Observatory in Chile, and it will have much better capability of detecting interstellar objects like Oumuamua, maybe find one every few months. And we hope to design a space mission that will come close to the next Oumuamua and take a close-up photograph, because a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. I will need to write it. So we want to get a high-resolution image of an Oumuamua-like object. I should say, just a few days ago, there was an important development that in 2019, I was asked to be interviewed about a meteor that fell close to the Bering Sea near Kamchatka. And I looked on the internet and realized to learn more about meteors, and I found a catalog that the US government compiled of meteors. And I went to my student, undergraduate student, Amir Siraj, and I told him, why don't you check this catalog? Maybe the fastest moving meteors came from outside the solar system. And he looked at the fastest one. It ended up being a head-on collision with the Earth. So it was actually bound to the sun. The high speed was a result of the fact that it was moving against the Earth. The second fastest turned out to be from outside the solar system, based on our calculations. So we wrote a scientific paper. But then the referees of the paper rejected it. They said, we don't believe the US government. There are no error bars here. And for me, it was obvious why the government didn't provide error bars. It's because they have systems that are so good. I mean, they don't want to reveal their precision to adversaries, to other countries. But the systems are able to tell whether a ballistic missile will hit Boston or New York City. So obviously they know the trajectory extremely well. But the referee rejected the paper. So what happened in the meantime, I tried to reach out to people from that have access to the classified information about the error bars. And it took 3 years since 2019 when we wrote this paper. And just last week, there was a letter publicized, it's also on Twitter, that from the Department of Defense Space Command, the US Space Command, that confirms that indeed this meteor that we identified at the 99.999% came from outside the solar system. Now, why is that important? Well, first, because this meteor was discovered in January 8th, 2014. So that was almost 4 years before Oumuamua. So in fact, that is the very first interstellar object. We don't know if it's natural or artificial. But if we go to the site where it landed, which was near Papua New Guinea, potentially we can find debris from that 2014 meteor. And that is a new window to put our hands on an interstellar object. It's a new opportunity for science to explore interstellar objects in the laboratory rather than flying close to them. It would be really challenging to land on such an object if it doesn't crash on Earth. So that's another thing, of course, that the Galileo Project would be interested in. So that's one branch, the interstellar objects. The second branch of the Galileo Project has to do with objects that the US government, cannot identify. And there was a report delivered to the US Congress by the Director of National Intelligence back in June 2021, saying that there are these objects and they don't know what they are. And As a result of that, a new office was established, signed into law by President Biden, that would start operations in June 2022 in the US government, looking at the classified data from all branches of government, trying to assemble it and see what can be said about these objects. And it's about time for science to get engaged and help the government figure out the nature of these objects. So that's the goal of the Galileo Project, the second goal of the Galileo Project. And we are, within the coming months, we will build the first telescope system on the roof of the Harvard College Observatory. It will have infrared and visible light cameras that monitor the entire sky at all times, and an audio and radio system that will also monitor the sky. And once this system works, we will make copies of it and put it in many different locations. And the idea is to look at these objects, any object that is in the sky. It's like a fishing expedition. And we will have artificial intelligence software that will identify whether they are natural, like a bird or a meteor or a lightning in the atmosphere, or whether they're human made, like a drone, a satellite, or an airplane. And if everything falls into these two categories, so be it. We clear up the fog and we can move on. But there is also a chance that there would be something that doesn't belong to these two categories, something from outside of this earth. And of course, that would be extremely interesting.
And just getting back to what you had covered earlier, the particular meteor that was discovered by Amir Siraj in 2019, if I'm not mistaken, that probably came from a galaxy that was called, or that has been called, HD1. And then we are talking about something probably 13.5 billion years of time or light years taken for that meteor or the light of that meteor to reach us. Now, this becomes really interesting when you look at the time span that you're talking about, right?
Well, I should explain. Okay. Uh, so these are two different discoveries. So one is the nearest object, this meteor, the nearest object to us that came from outside the solar system, outside of our local cosmic neighborhood. It was, of course, announced as a result of this letter from that I mentioned before from the Department of Defense, confirming the discovery that we made with Amir Siraj. Then a day later, there was a press release on a completely different piece of work that I did with a different person, Fabio Pacucci, a postdoc of mine, and it's completely separate from that. That's concerning HD1, and that is a galaxy that is the farthest that we have ever detected from outside our cosmic neighborhood. So these are two different objects. The meteor is the nearest one, and the galaxy HD1 is the farthest one that we had seen so far. And the beautiful thing is that both announcements came at one day after the other, so they came within the same week. And for me, it's the greatest thrill that a scientist can have to be involved in such a both of these discoveries of the nearest and the farthest objects from outside of our cosmic neighborhood. And I can say a few words about HD1. It's completely separate from the meteor story. And that is a galaxy discovered by data from a number of telescopes. And what's interesting about it is that it emits much more light than in the ultraviolet than one would expect. And that could be explained by two things: either that it has a lot of massive stars, and uh, which is expected for the first generation of stars in the early universe. This galaxy existed just 300 million years after the Big Bang and was one of the earliest generation of
Wow.
galaxies. And the second possible explanation is that the ultraviolet radiation is emitted by a very massive black hole, 100 million times the mass of the sun. And of course, one can distinguish between the two possibilities. One way to distinguish is looking for X-ray emission, and there is the Chandra, named after the Indian astrophysicist Chandrasekhar. Um, uh, the Chandra X-ray satellite observatory is capable of detecting the X-rays if indeed there is a black hole in that galaxy. And the second possible way to distinguish a black hole from massive stars is by looking at the image with the James Webb Space Telescope. So imaging this galaxy with a bigger telescope than was used, just to try and see if it's extended, if the image is extended. Because if it's a black hole, it should be point-like, whereas if it's stars, you should see a fuzz, some extended image. And so there are two ways to tell whether it's a black hole or stars. But it's fascinating that we are able to reach out. It took the light 13.5 billion years to reach us. And that's amazing because, of course, you might say, oh, the galaxy is 13.5 billion light years away. That's not true, because it was 13.5 billion light years when the light was emitted from it. And by now, it's actually farther away because of the expansion of the universe. So you have to take that into account. It's more like 40 billion light years away right now. The other thing to keep in mind is the universe is expanding in a way that accelerates over time. In other words, it's not just expanding, the speed of the expansion is growing over time right now. And what that means is that this galaxy that emitted its light very early on, by now is potentially moving away from us faster than light. So we won't be able to know much about its future if we continue to monitor it, for billions of years. Eventually, there will be no information because the galaxy is accelerating away from us and separated from us faster than light.
That's really amazing when you talk about these distances for us listening to you, because you spoke about these first generation of stars. And when you say first generation of stars within that galaxy, were these the first to be formed or created? Because, correct me if I'm wrong, they've also been labeled as population 3 stars. And is that because there is a population 1 and 2? Just so that we can understand what a population 3 star is.
Yes. So when astronomers looked at the Milky Way galaxy, they found different populations of stars, and one of them was made more recently, and the other one before that. And the way you can tell is how much heavy elements the stars have over time. The gas out of which the stars form is enriched with heavy elements because of supernova explosions. There are some stars that are more massive than 8 times the mass of the sun. They explode and they basically enrich the surrounding medium with heavy elements that were not produced in the Big Bang. So the carbon and oxygen and all these heavy elements that our body is made of, that life is made possible by, without carbon and oxygen, we wouldn't exist. All of this was not produced in the Big Bang. And we are sort of an afterthought. That's another reason to think that we are not central players. Uh, the materials that make us possible were made in the interior of stars. And you can think of a star just as a nuclear reactor, basically, that burns through fusion, not fission. It doesn't break heavy elements, but rather fuse together hydrogen and helium nuclei. And it's able to do that because of the very high temperatures. It's very hot in the middle of a star. So, somehow there were clouds of gas made, and out of them, they fragmented into stars. And stars are dense enough and hot enough to act as nuclear reactors, and they are held together by gravity. And so the very massive stars eventually explode, and in the explosion they spew out all the heavy elements that were in their gut, that were made in their gut. And as a result of that, the next generation of stars inherits these heavy elements, and you can tell that there are different populations. So that's population 1, population 2. But both of these populations had significant abundance of heavy elements, and population 3 is something that, we are starting to see hints for, but it was a concept that was theoretically suggested because, the very first stars had no heavy elements. They are called population 3. They should have burned hydrogen or fused hydrogen and helium. Um, and that was the only constituents that they were using in their interior. They didn't have any heavy elements at all. And theoretically, it turns out, if you do the calculation, that the early gas clouds that made them, since they didn't have heavy elements at all, they couldn't fragment into small pieces. They had made big stars. And the theoretical expectation is that the first generation of stars, the population 3 stars, were mostly massive, much more massive than the sun, at least 10 times the mass of the sun, maybe 100 times. Um, and that was a theoretical expectation. Uh, we have not yet confirmed it, because these stars are short-lived when they are massive. But there will be data like the one we have on HD1 that may suggest that indeed we are looking at a galaxy that is made mostly of massive stars. And these are called population 3, if indeed that's the origin of the light in that galaxy.
Right. Then, in that case, because of the size that you've mentioned about or the activity within them, they would be easier to detect at the moment, considering the amount of energy or light that they did emit if they did explode. Is that the right way to think
Yeah,
about it?
yeah. So massive stars are easier for us to see. They have a short lifetime, just like the big stars in Hollywood. They have, but uh, in fact, just a couple of weeks ago, there was another discovery of a single star that happened to lie behind what we call a gravitational lens, and in this case, the lens is a cluster of galaxies. And basically, according to Einstein's theory of gravity, light can be bent by gravity, and you can focus it. And this is called the gravitational lens, where gravity focuses light from a source behind the concentration of mass that makes up the lens. And it so happened that a very massive star happened to lie just behind what we call a caustic, just behind the place where you get the largest magnification. And we can see that star. So, and that star, is from a billion years after the Big Bang, was very early in the evolution of the universe, and it's the first time that a single star was imaged. And uh, the, so that was a major discovery. Of course, another way to find a single star is, even without lensing, without magnifying the light, you can see an explosion. And the brightest explosions that we know about are called gamma ray bursts, and they originate from massive stars. And indeed, there is a gamma ray burst that was detected very early on in the universe, and that represents the farthest single star that we have detected. Um, Finally, there is another way of learning about massive stars, and that is from the remnant they leave behind. If they are very massive, let's say 100 times the mass of the sun, or maybe 50 times the mass of the sun, they end up making a black hole when they collapse. They cannot leave any other relic than a black hole. And the black hole that they make, if it finds another black hole near it, it could make a pair of black holes. And when those black holes spiral around if they make a binary, a pair that is moving around a common center of mass, then there is emission of gravitational waves. And we can see those gravitational waves. These are just ripples in space and time that are generated because of the motion. You can think of it as two fish moving on the surface of a pond. And because of that, they generate waves that propagate outwards. And you can see the waves and then infer that there are fish somewhere.
Yeah.
And beauty of that is you don't need to detect any light. I mean, black holes do not emit light. But you can detect the gravitational waves, and the LIGO, Virgo, and Kagra observatories for gravitational waves they keep detecting gravitational waves from very massive black holes 50 solar masses or so uh, from the edge of the universe that were potentially the relics, the leftover from those massive stars that existed early on.
Right, these massive stars, like you said, are very interesting, and definitely they do know how to take jokes as well. We've been cracking a lot and getting them wrong and right over all these years, right? But coming to another very interesting concept that if you could touch on is you've mentioned about AI astronauts. Now, in the last, I would say, couple of years, there's been a lot of action on social media. There are revelations. There are people who are talking about a lot of stuff that they've encountered, and we all know what happened with the jet that was following a particular object. Now, how do you place these AI astronauts, and could you just tell us what these are?
Yes. So we have artificial intelligence systems that are involved in driving cars right now. And in my view, eventually we will use artificial intelligence systems in space, not in the very distant future, perhaps within a decade. And right now we have the Perseverance rover on the surface of Mars, but it's pretty much a robot that is operated by instructions from engineers in the Jet Propulsion Lab at Pasadena. Um, but in the future, you can imagine artificial intelligence astronauts. And what I mean by that is systems that are fully autonomous, that they don't need guidance from the sender. And that's extremely helpful when you go to large distances. For example, the nearest star is 4 light years away. And if we wanted to guide the system, it would take 4 years for the signal to reach there. It makes very little sense. And it would take tens of thousands of years for light to cross the Milky Way galaxy. So what you want are systems that are autonomous, that are able to learn from experience through machine learning. And therefore, if we can imagine doing that, sending those AI astronauts, and by the way, humans over the centuries tried to preserve something of themselves by building monuments, like having statues or paintings drawn based on their physical appearance. I think that makes little sense that, in fact, within less than a billion years, the sun will expand and burn up everything on Earth. If you want to preserve something of yourself in the long future, you would like to send an AI astronaut that would survive and last longer than the sun. Uh, and it could carry your flame of consciousness, your guiding principles, and promote them in space to whatever destination you send it. So if we can imagine doing that, someone else might have done it already, because I don't think Albert Einstein was the smartest scientist that ever lived since the Big Bang, 13.8 billion years ago. I think it's very likely there was a smarter scientist on another planet around another star that lived a billion years ago. And the civilization that benefited from that scientist could have launched probes and AI astronauts to space a billion years ago. So they may be around us. And the only way to find out is to look through our telescopes. And that's pretty much what the Galileo Project is all about. And as of now, we have $2 million, so we can maybe make 5 telescope systems or so. But what we really need to do a comprehensive search of the sky based on the reports from the US government and so forth is to have hundreds of such telescope systems. So we need about $100 million to accomplish the task. And if you think about it, it's not a large scientific budget. I mean, the biggest science projects cost $10 billion. This is just 1% of that. And moreover, this topic that we are focusing on is of great interest to the public. It would have huge impact on society, on humanity, if we find something. So I think that we should definitely spend this money and search. We spent 100 times more searching for dark matter. We haven't found anything. It's a search in the dark. But in my mind, this search is of much greater consequences. And since it was never done before, there is a chance that we will find low hanging fruit. And it's just like the poem by Robert Frost, who said that he took He preferred to take the road not taken in the woods because that made all the difference.
Right. And I heard you saying through these AI astronauts, something else that you've mentioned is self replicating spacecraft. You could carry the flame of consciousness of humanity into the universe. And the reason I picked on that is I come from a very spiritually rich country, and we tend to spiritually start with our thoughts and then get into the philosophical realm. How important do you see as we move forward, probably into the next century and year on? How important do you think is the connection between philosophy, spirituality, and how we plan and what we do to prepare for what we're going to actually find?
Oh, I think it's extremely important. A few months ago, I was on a panel at the Washington National Cathedral together with Jeff Bezos, uh, and he was talking about how watching Star Trek as a kid inspired him to promote space tourism as a commercial enterprise. And he was dreaming about launching 1 trillion people to space and considering the Earth as a national park, just visiting it once a month or so. And I thought to myself, I completely disagree with that because I thought to myself that going to space is not, there is no business plan to leaving the solar system. It shouldn't be done for commercial benefits. The only reason to leave the solar system is to search for the unknown, which is spirituality. Uh, and that could be the only motivation for us to, extend our existence beyond this earth. And I do think spirituality and philosophy are extremely important in seeing the big picture because, why do we live? What's the meaning of our life? It's definitely not the money that we make that cannot give us meaning. And for me, it's understanding uh, the play that we are in. What is on the stage, first of all. So that means looking out. Are there other actors? And if there are other actors, perhaps we can ask for their advice about what they think the play is about. I can give you an example. There was someone that uh, stared at my home a few months ago that my wife noticed. She was sitting in the porch and she saw a person on the street looking at our home for a long time. And she was worried that someone is stalking me. So she said, why don't you check what's going on there? And so I went to that person and I asked, who are you? Why are you looking at our home? And he said, well, I used to live in this house 50 years ago. And I said to him, oh, so why don't you come over and have a look at our backyard? And he said, my father, when I was a young kid 50 years ago, my father buried a cat that we had named Tiger in the backyard. And I said, well, I know that name because I saw a tombstone with the name Tiger on it in our backyard. And of course, I didn't know what's under it. And I was hoping it's not a tiger. It turns out to be a cat. I took this person and we found the tombstone that says Tiger from 50 years ago. And presumably a cat is buried underneath. So the moral of this story is that, people that used to share your space a long time ago know more about your immediate environment than you know. And this person knew more about my house than I know because he lived here 50 years ago. So we should welcome visitors from far away if they were around for a long time because we can learn from them. The the ancient Greeks, the philosophers, they welcomed guests. That was the highest um, virtue that they assigned to welcome guests. It was called xenia, Xenia, and um, presumably they did it because the guests were bringing new information about the outside world. They could learn from it, and they realized it's to their benefit. And so my point is, we should advocate for interstellar xenia, welcome our interstellar visitors because we can learn from them, even about our solar system, our immediate neighborhood. They might have been around for longer than we did. Recorded human history is only 10,000 years old. It's 1 millionth of the age of the universe. So, coming back to your question, I think spirituality is the most important element here. It's not making money. And a lot of people engaged in the technological world are thinking about money, but I just came back from this Bitcoin 2022 conference, and indeed, the question is what to do with the money.
Mm. And thank you so much for sharing that story about Tiger. I think that is the first time I've heard about it, and that was really touching, and probably the best way or analogy to use when you talk about visitors. Period. Whether they are from the neighborhood, whether they are from space, or whether they are from another period in time. And you mentioned about spirituality because it was a question from me, and I was thinking while you said it that probably the arts as well, because when you talk about imagination and you're talking about consciousness, then you talk about imagination. And interestingly, I found a very good analogy here because I wouldn't know if you remember this, but in Arthur Clarke's award-winning 1973 novel, which was called Rendezvous with Rama, a mysterious 50-kilometer cylindrical spacecraft enters the solar system, and a space mission is mounted to intercept and study it. And how eerie is that to what we're just talking about?
Oh yeah, that's very interesting actually, and there is another interesting connection that I called the project the Galileo Project after Galileo Galilei, and the reason was simple: that 4 centuries ago he argued by looking through the telescope that the Earth is not at the center of the universe, that it's in fact moving around the sun. And philosophers at the time argued that they know the answer. They don't want to look through his telescope, and they put him in house arrest. Today, they would have canceled him on social media. And if you were to ask those philosophers to design a rocket that would reach Mars, they will never get there because they thought that Mars moves around the Earth. And so that's why we call the project Galileo, because we want to find the answer by looking through our telescopes, by being guided by evidence. And if Galileo was alive today, we would have invited him to be a honorary member. But the name Galileo was drawn from the northern part of Israel called Galilee. And Galilee means in Hebrew a cylinder. So here is an interesting connection between Rendezvous with Rama, that has a cylindrical shape, and the name Galileo. It's just an anecdote. I mean, it has nothing deeper. But the point I wanted to make is indeed art, humanities, spirituality are extremely important in motivating us. However, we should always be guided by evidence, which is the scientific method. We should collect as much evidence as possible with instruments and analyze it in a way that is, completely agnostic. Really, my hope is that in the future we will involve artificial intelligence also in science, because one of the problems I see with scientists is that after a while they get very attached to their ego, and that's a real problem, because once you are attached to your ego, your goals change. You are trying to convince other people that you are smart rather than trying to figure out what nature is. So if you are trying to convince other scientists that you are smart, you will do intellectual gymnastics, you will do mathematical manipulations that demonstrate that you are smart, irrespective of whether they describe reality or not. And the entire reward system changes. And you can have a whole community of physicists, theoretical physicists, that work for half a century on a concept called string theory without any test, experimental test, and they just show to each other that they are smart, that they can do mathematics in a very sophisticated way. But to me, as a physicist, that doesn't promote our knowledge about reality. In order to learn about reality, we need to obtain data. And if we see an object that looks weird, you don't need fancy mathematics in extra dimensions to describe it. And I don't care about it. I just want to know if it's artificial, it means there is another civilization out there. And that discovery by itself, that knowledge, is not about demonstrating that we are smart. It's not about showing off. It's exactly the opposite. And that's also the criticism I have about, the current mode of space exploration, because there were a number of wealthy individuals that flew themselves to space, and that was just 1% above the Earth surface, 1% of the Earth radius, that they lifted their body to. And they said, oh, we are now in space. My point is, showing off in space is an oxymoron, because the size of the observable universe is 10 to the power 19 times bigger than the radius of the Earth. So you cannot brag, you cannot show off in space. Space is huge. So once again, we are surrendering to our ego. We are using space to demonstrate that we are powerful. We are using science to demonstrate that we are smart. This is not really the objective. The objective is to figure out what's around us by looking at data. And perhaps artificial intelligence scientists would not have an attachment to their ego. They would just look at the data. So when the data shows an object different from a rock, the artificial intelligence system would say, that's interesting. Let's get more data on it. It doesn't look like a comet or an asteroid. Whereas an astronomer, a mainstream astronomer, would say, oh no, forget about it. It's just a rock of a type that we've never seen before.
And that reminds me of what you've also said earlier when you spoke about getting into space or getting up to a particular limited altitude in space is very similar to what you've spoken about an ant clinging on to a grain of sand on a beach.
Yeah. So the other aspect, I mean, you can see it in politics, right? That leaders, emperors or kings in the past, and nowadays Putin, were very proud of themselves, trying to conquer a piece of land on Earth. And if you think about the big scheme of things, it's not very impressive, because there are more habitable planets like the Earth in the observable volume of the universe than there are grains of sand on all beaches on Earth. So even if you conquer the entire grain of sand, it's nothing in the big scheme of things. You can't, it shouldn't give you satisfaction. And it's just like an ant hugging a single grain of sand on the landscape of a huge beach. So my point is, look at the big picture, and that will teach you a sense of modesty, that the accomplishments that we are very proud of are not that significant. And also it would teach you to treat other people with respect, because if all of us are, as Oscar Wilde said, we are all in the gutter, but some of us are looking at the stars.
Right, that's interesting. You mentioned that because, in fact, just the other day, I managed to speak to about a few of my friends, and a question I was posing to them is, when is the last time you stared up at the sky? And you'd be surprised. Was it 24 hours? Was it 48 hours? You can get through about a year of people just not looking up at the sky. And I would ask everybody, when is the last time you looked up? Forget the rest. And I know we are putting up telescopes, but it would be interesting to ask this question to more people.
Right. I mean, the point is, I wrote a few weeks ago, I wrote an equation that is a substitute for the Drake equation. The Drake equation quantifies the likelihood that we will see a radio signal from a source. But that is a completely different question than asking what's the chance that we will discover an object within a certain survey. So it's just related to the volume of the survey and the number of objects per unit volume that you have. And it's completely different than the Drake equation. But and of course, if you use the Earth as a fishing net for meteors, then it also depends on the speed, the characteristic speed of those objects. But there is another factor that needs to be put in the equation, which I call the ostrich factor. If all of us will say, let's not look, if we say extraordinary claims require extraordinary evidence, forget about it, it's a rock of a type that we've never seen before, anything we see in the sky is a rock, and so forth, then we will not find anything. So, the likelihood of finding something depends also on us, not just on them, the senders. And the mistake made by humans very often is because they are attracted to virtual realities that bring them pleasure, things that are not necessarily the reality we live in, then we often miss the clues because we are not searching for them. If you're not ready to discover wonderful things, you will never find them. And I think that's the most important lesson that I learned, that in fact humans can establish communities, and you find it in academia, you find it in religion, you find it in many places, in politics. They can establish a community that decides about the truth, decides what they believe in, and does not seek evidence to support it. And of course, that's called a bubble, an intellectual bubble. And if you have enough people in that community, you will feel very comfortable because everyone will support everyone. If that community is in academia, it can give its members prizes, awards for things. It's really entertaining sometimes, because I saw a very major award in the physics community being awarded for the proposal of a speculative idea. Okay, speculative meaning it was not tested experimentally. And the award was given to the person who proposed it. And then the experiment was done and they didn't find it. So they gave the same award to the person who disproved the idea. And I said, well, we just went in a circle. We didn't learn anything new.
Yeah.
So still, there were two awards given when we got back to our starting point. And, that, so in a way, academia can be self-fulfilling in the sense that if people agree that they don't need to seek evidence, that they can work on a subject for half a century, just doing mathematical gymnastics and impressing each other, giving each other awards. If those gatekeepers that make appointments, allocate funds, if they are part of the club, then it's a self-fulfilling prophecy. And it's just like many other structures in society that operate the same way, as I mentioned before. And it happens in politics, of course. But it's unfortunate if it happens in science, because physics is all about learning the new things about the reality we live in. And for that, you need to be open-minded to the evidence rather than assume that you know the answer in advance. And, there was this colloquium at Harvard about Oumuamua. And when I left the room, together with a colleague of mine that worked on rocks for decades, my colleague said, Oumuamua is so weird, I wish it never existed. And that to me is contrary to the scientific method. You should be excited about something that looks weird, because anomalies is nature's way of telling you that you are missing something. Nature is telling you are missing something. Get more evidence and figure out what you're missing. So you should be excited about learning something new rather than arguing or pretending to be an expert that knows everything that will come along based on the past knowledge, which is pretty much the approach that people take to flatter their ego. They say, well, I worked so hard all my life to establish my status as an expert. Therefore, anything that comes along, I should pretend that I can explain it using my past knowledge. And therefore, in order for me to get honors and awards, I should say nothing, there is nothing new under the sun. I can explain everything. I know a lot. And that goes contrary to the spirit of science, which is all about discovering new things that we don't know. And for that, you need to be modest. Just suppress your arrogance and consider nature as your tutor, as your teacher that gives you anomalies so that you can learn something new. And one big example is quantum mechanics. 100 years ago, it was not known, and people that worked on classical physics said, that pretty much is the end of science, the end of physics. There is nothing else to be discovered. We know pretty much everything except for some dark clouds. And ended up, a century ago, we discovered quantum mechanics changed completely the way we think about reality. And now all the gadgets that we have, all the electronic gadgets, are based on our knowledge of quantum mechanics. So those lessons should be that should teach us modesty. It should teach us to be humble and try to seek evidence, because that's the only way by which we can learn the truth.
Right. And with this Galileo project on UAPs, we do hear and we do know that that is also an active community. And there have been instances where it's spoken about not just an interstellar process or an interstellar activity, but it could be interdimensional as well. Now, how open are you to that? And where do you see the Galileo project, or how do you see the Galileo project tackling these queries that will come up, or not making the same mistakes that other projects similarly went out looking for and were not able to be successful, at least so far? How do you think the Galileo project is going to take those on board?
Well, I talked about it at the Bitcoin 2022, and we definitely know that our knowledge of physics is incomplete. And the reason we know that is because, for example, Einstein's theory of gravity breaks down. There are two prominent examples for that. One is at the center of a black hole. We don't know where the matter that makes the black hole goes to, because Einstein's theory breaks down in the middle of a black hole. And another place where it breaks down is at the Big Bang. If you go back in time, there was a point in time where the density of matter was infinite, and we just don't know what happened before the Big Bang, how the universe started. It's possible that it was made in the laboratory of an advanced civilization that knows how to unify quantum mechanics and gravity. We don't know how to do that. We don't know what happened there. And so our knowledge is incomplete. And of course, even in the context of quantum mechanics itself, we do not fully understand what's behind it. It's counterintuitive, and Albert Einstein had difficulties with it. He proposed even a way of showing that you can understand it in a traditional way, and he was wrong. By now, the experiments were done, and it's really mind-boggling to try and figure out what quantum mechanics means about reality. And so it's clear that we don't have a complete understanding of reality, because we can't unify quantum mechanics and gravity. We don't fully understand what quantum mechanics means. So I would say, given that our understanding is incomplete, it's quite possible that there are things, I wouldn't say uh, that they relate to multi-dimensions necessarily. That's just a fashionable thing for people to discuss right now, but we don't have any evidence for extra dimensions at the moment. But one way to find the answer to how to unify quantum mechanics and gravity is to look around, as so we can look at the early universe, we can look at black holes, but we can also look at objects that arrive to us from far away, and study them, and they may have clues. Because, for example, if they are artificial, the civilization that produced them, they may know, for example, what dark matter is, and they could, since it's the most abundant substance in the universe by a factor of 5 relative to ordinary matter, they could harvest dark matter and use it as rocket fuel. Why not? If you know how to use it, how to engineer it, you can use it as rocket fuel. To us, it would look invisible because it's dark matter. And the same about the vacuum. We know that the vacuum, for example, has some energy density or mass density, and that's causing the accelerated expansion of the universe that I was talking about before. And if you find a way to use the vacuum energy, again, it's everywhere. It's very abundant. Uh, we just don't know how to engineer it, how to excavate it. And it's possible that another civilization that has 1,000,000 years of science instead of 1 century of science knows that. And it's also possible that our knowledge is incomplete in many other ways. So I'm completely open-minded. I think that, a cave dweller can find a cell phone without being able to reverse engineer it. The caveman would be able to say that's not a rock. Okay. So the aim of the Galileo project, just like a caveman, is to say, here is an object that is not a rock. I mean, trying to reverse engineer it will depend on the technological gap between us and them, whoever produced that. If the technological gap is huge, it would look like magic to us. We would never be able to reverse engineer it.
Yeah, and we are all with you on this. And I do know that I have extended the time that we actually took from you. But before we let you go, Avi, one is a couple of points here. If you could talk to everybody listening, and you do know that most of our audience are students and university going kids, but everybody who's listening, how can they be part of the Galileo project? What can they do? Where can they go and find this information? But before that, if I could ask you to try, and I'm going to try this question with you, I don't know if I'm going to be successful, but if you had to take off your science hat and we were just talking to you, like you said, in the good old days, I do know you speak a lot about where you came from at your beginnings on the farm, and we were having a conversation. And I had to ask you, so do you think that we are alone in the universe? What would your answer be?
Yeah, so for the first question, I should say my hope is with the young people, the young generation, because they don't carry a baggage. They are open minded. They are not as motivated by their ego as the more senior people. And um, I try to maintain my childhood curiosity because as a kid, I was really frustrated asking a difficult question at dinner and seeing the adults in the room dismissing the question just because they didn't know the answer. And so I very much hope that the young generation of today will bring us to major discoveries in the future. And in terms of participation in the Galileo Project, we have a website. If you just put Galileo Project Harvard University, you'll find it. And there is a form in one of the tabs that allows you to suggest that if you are interested in joining, that you have to fill some details about yourself, and the project will get in touch with you if we decide that indeed we need that expertise. With respect to your other question about whether we are alone, out of a sense of modesty, I would say not only that we are not alone, it's very likely that we are sort of not the most intelligent, because when I teach a class at Harvard to undergraduates, I usually tell them half of you are below the median in the class, and they get upset, but that is a statistical fact that the median in any class, irrespective of which class you attend, the median is defined such that half the class is below the median. So all I was saying is just statistical tautology. I was just saying something that is obviously correct, that half of the class is below the median. But of course, all the students at Harvard, they want to believe that they are the top 1 or 2%. And they have a hard time psychologically dealing with it. So I would apply the same to our civilization. I would say most likely we are somewhere in the middle of the distribution of intelligences that ever existed. It doesn't mean that right now, maybe by chance, all the others are dead and we are the only intelligent right now. But over the billions of years that stars existed, there must have been smarter beings around. And my point is, let's not argue about it. Let's just look for any evidence they left behind.
Great. And once again, from everyone here in India and Indian genes, I would like to thank you for taking time. Hope we can speak to you again. But before I let you go, I wanted to end with, you spoke about a beautiful story about Galileo Galilei and his name. And since the project is the Galileo Project, we were talking about art and what else. But I just wanted to probably highlight this to our listeners as well. And I'm not sure if you know it. I'm sure you know about it. But Galileo's father actually was a music composer. He was a music theorist, and Galileo had a brother who was also a musician. So there you have a little bit of art in everyone, right?
Yes, and I would argue that's the most important element. Spirituality is what's driving us to study the unknown.
Once again, thank you so much, Avi, and hope to talk to you again.
Thank you. It was a pleasure.
इस हब हॉपर ओरिजिनल को सुनने के लिए आपका शुक्रिया। अगर आप भी अपना पॉडकास्ट लॉन्च करना चाहते हैं तो हब हॉपर स्टूडियो वेबसाइट पे रजिस्टर करें और 1 मिनट के अंदर अंदर अपना खुद का पॉडकास्ट लॉन्च करें। यही नहीं, स्टूडियो देता है आपको पूरी आजादी कहीं भी कभी भी अपना पॉडकास्ट लॉन्च करने की, सिर्फ 3 आसान स्टेप्स में। तो साथ में अपना पॉडकास्ट शुरू करने के लिए तैयार? जस्ट हॉप ऑन हब हॉपर, सिंपली कंटेंट।